This presentation is called Examples and Solutions, and a subtitle, and this is for my students. You are encouraged to compete with me because most of the suggestions to improve charts in this presentation can be challenged by anybody. It is a collection of examples of charts that need correction to send a clearer message. In a classroom setting, students are encouraged to compete with me, as you have seen in the title slide. The examples are divided into these sections. A section to examine published charts, find the problem and suggest a better chart. Another section to convert table of data into proper charts. The third section is to convert paragraph to table, then to graph. Then a section on improving some graphs to show a different way of presentation. And then to look at graphs produced by pivot chart. And the last section is a bit different because it shows how you can have another look at the design of tables to avoid repetition. Analyze and correct. This chart is a comparison between hydraulic and proposed system dredging. It is multiple comparison, but I don't see any reason for joining the markers or even using a line chart. Therefore, I used this chart. It's a clustered bar chart that allows me to see the differences and also have the names of the locations clearer to read. A second example is a timeline showing the values of an indicator through a winter season in 3 different irrigation districts for certain months starting from October 2008 to April 2009. Again, this is a trend line and the distances on the x-axis are the same. Therefore, the type of graph is not the proper one, and my suggestion is to use a line graph instead of the clustered column. This is another example measuring pH values along Rosetta branch at different locations with different kilometers from the delta barrage, and the distances are not the same. And the person who did the chart, he is measuring pH on east, middle and west of the channel, and because it's a trend line with distance this time, unequal distances, therefore to improve the chart we have to convert it into this is a line chart. How do I know that it is line chart? Because the distances between the tick marks and the markers are the same, and the markers are in the middle between the two tick marks, and the values on the x-axis appear on the x-axis here. Of course, this is not correct because it does not show the relative distances between the kilometers. Therefore, the better one is to choose an XY scatter chart like this one. This is another example for post-secondary vocational education for general and technical students, and what we noticed here that the summation of the two columns comes up to 100, and this is a special case of data. Therefore, we need a 100 stacked diagram to allow us to see that they all add to 100% and improve the reading of the x-axis. And my solution to this is to convert this chart into a stacked bar chart that allows me to see data that the sum of the percent is 100 in a clearer way. This is another crowded chart that shows the drainage reuse and drainage outflow to the sea in the Nile Delta, and this should not be added because we cannot add oranges to apples. And again, it's a timeline with equal time increments. Time increments is 1 year. Therefore, the proper thing is to just put this data in a table first, then use a line graph. Therefore, we have two lines showing the trends with time. And these are not stacked, these are the values in the tables. The other section is to use the proper graph. This is data for the irrigation seasons for winter and summer, showing the irrigation date, the agriculture date, and the harvest date. And we wanted to present this in a proper way, or this is my suggestion at least. Therefore, I used a stacked bar chart and moving the lower part to see very clearly the duration of each crop and if it is summer or winter. The x-axis is date axis, and it is of course shows the proper dates of the start and finish of the irrigation season for each crop. This is in higher education or in any type of irrigation where they have detailed grades for marks starting from A and ending with F, and we like to show this table in a graph format showing how the limits are put for the different grades. And here I used a bar chart that shows how the differences are made between A and A minus, between A minus and B plus. This is another example where we have canals with surveyed area and location of intake in kilometrage, and some of it is to the right and some of it is to the left of the canal. We look here, I put the data in a spreadsheet, and then to differentiate between left and right I give it a different sign. Therefore we get this thing here. The horizontal axis is a kilometrage, and the discharge is shown on the y-axis, and because of the signs I made, I was able to differentiate between the left side and right side of the canal. These labels here, I put them manually. They are not generated automatically. Another example is the cropping pattern of cultivated areas at certain watershed at certain time, summer 2008 in Fiddan. And it's a very good example of stacked column, but here are two graphs. The one to the left shows how the crops is distributed for each of the districts, and the one to the right shows the districts, and for each district how the crops are distributed. This is a challenging table because it shows the cross sections on the Nasser Lake, name and number, as the distance from Aswan High Dam and the thickness of sediment deposition, and I want to represent this graphically. It's a bit difficult, but this is my suggestion. I have the distance upstream High Aswan Dam in kilometers, and I have the location in number and by name, and the thickness of sediment in meters. This is an example of a stacked clustered graph that is not in the main list of charts in Excel, and I have to use empty cells and rearrange them this way to be able to come up with the stacked clustered column showing with time the difference consumption of poultry, lamb, beef and other types of food, as you can see. Another example which has to do with the Idkulate in the northern part of Egypt, and we have data on the boundary lengths and the total area. And what we want to do is to make a sketch for a suitable graph showing the changes of length and area with time, which is another timeline, but the problem is they are different in orders of magnitude between boundary length and area in square kilometers. This is a map to show you where Lake Idko is. It's one of the smallest lakes in the northern coast, and this is what happened to the area and perimeter with time. And this is when we plot it as a line graph. We cannot see the differences in the area because the numbers are very small. I have to use a secondary axis, as you can see here. If you use a secondary axis and the x-axis is time in years, you get a better graph. Here is bathymetric representation using GIS for the khors in Nasser Lake. We have 3 khors: Kalabsha, Allaki and Toshka. We have surface area, an annual water volume in billion cubic meter, and annual evaporation in billion cubic meter. How to present that? We want also again to show you where the location of the khors on the Nasser lake. Then this is how we do the difference between area and percent for the 3 khors. Also for the volume, this is for area, and for the volume we use a stock chart that shows the minimum, the maximum and the average values. The same thing for evaporation in billion cubic meters. Another table that it's also a timeline shows the rural and urban population in all the Arab countries from the year 2005 to the year 2014. And I used an area chart which is looks like that, and it's of course cumulative, but a better or a different way of looking at data is to use a stacked line. Stacked line is one of the subtypes of the line charts, and it allows us to draw these 2 lines. This line is not the values, but these are the stacked value, meaning we add rural to urban to see the total population. The next section is to convert paragraph into table and to turn the table into a graph. Here is part of a paper that shows us the cost of irrigation improvement project main system and MESCAs is different per region and contract. The cost of actual contracts has been as follows, and the paragraph doesn't look okay. We put it in a table and we convert the table into chart. The problem with chart is that the number of contracts is very small compared to the coast or the area in Faddan. Therefore, I used a logarithmic Y scale to be able to read with some better clarity the numbers in the table, considering the data in the three columns. This is another table that shows the same data, excluding the number of contracts. And because of the difference in orders of magnitude, I used a logarithmic scale for the area in Faddan and a secondary axis for the coast with normal scale, as you can see. Excel allows us to do a lot of things. This is another example, water quality measurements compared to the values in the FAO standards. Here, this is the table. We have different chemical parameters. We have low value, high value, and maximum value dedicated by FAO. And because of the numbers are many orders of magnitude different, I use a logarithmic scale and I use markers only to show the low, high, and maximum. And by looking at the graph, we can know the parameters which goes beyond the limits, like cobalt here. Another example which has to do with education, higher engineering education across the country. It is very difficult to read the paragraph and know the difference in numbers. Therefore, I put this in a table. Enrollment in percent in Cairo, North Valley and South Valley for a timeline, as you can see. Therefore, we can use the enrollment percentage in a line graph, and we use the institutes on a different graph because it is difficult to combine them in one graph. Another paragraph, it shows chemical analysis in the cores of the Nasser Lake, the name of the core and the site, and also the value of the concentration in milligram per liter. Here we put them in a table. We put the parameter, the low, high, and the location in terms of name of the core and section number for low concentration and for high concentration. And we will do this. I use the stock diagram without average, and again the names of the cores with cross-section number I put manually to be able to produce this one. This section is to improve graphs. Improve graphs means it is an acceptable graph like this one. It has a secondary axis and it's a combo chart combining clustered column with line graph. But the problem here is I wanted to look at it from a different angle. Therefore, I put it like this. I put the floods and droughts and flash floods and storms in one clustered column, as you can see. Of course, here I used a stacked column chart because I saw that using the stacked column allows me to see the relative amounts of the effects of climate disasters in the Arab region better than the stacked line chart. Here is another example where we have certain time duration from 76 to 81, from 81 to 91, from 91 to 2000, showing the different parts of the world. This is a classification of the World Bank. And my problem here is that I wanted to see the timeline as x-axis. Therefore, I changed this, as you can see, and I put the time duration on the x-axis. This is my other way of looking at things, and we see here the growth rate of public agricultural expenditure in the 6 different geographical locations as shown. Here is Egypt total population by main age group. Of course, the summation of the 3 columns is 100. This is one. Another thing, this is a timeline, and what's interesting that this is a kind of a summarized population pyramid. Therefore, my first thing is, because I discovered that they add up to 100, I use them like this, where the time here is, because they are not the same distance, I used a stacked column to see the different proportion of the age ranges from 0 to 14 years, from 15 to 64, and those like me above 65 years old. But a better visualization from my point of view is to use a population pyramid like this one. I put the different age ranges with time starting from 1950 and ending with 2100. Another example of the CO2 equivalent in kilograms for different means of transportation. The graph is a bit crowded, but here the reason I want to look at it from a different angle, because I wanted to know the rank to sort this data. Therefore, I entered the data and I used the same bar chart but sorted from largest to lowest. This section is about pivot table, and there is a lot of data and a lot of calculated numbers and raw numbers. Therefore, to simplify this table, I put it here, where I have the gender and if it is urban or rural, and the number in 1000. Then I used the pivot table to produce this pivot chart, as you can see, to see the difference between rural and urban population for males and females. These are the different education levels: technical, intermediate, university and above, intermediate and less than university, less than intermediate, illiterate, intermediate, and read and write. Here is just different, because the filter shows geographical here and shows gender here, using the filter option of the pivot table. In order to plot the data in the previous chart, I thought I may use a cluster stacked chart. Therefore, I rearranged the data, putting the empty cells I talked about in a previous slide, and this is what I get. I was able, in one chart, to see male and female, and also to see rural and urban in the same chart, using the clustered stacked bar chart here. Second look at tables is a bit different, because there is no charts. I just look at some tables. One of them is a research. It's an experimental investigation where there is a lot of repetition. You can see here there is a lot of repetition here, a lot of the same value here, the same value here, and the same value here. Therefore, there are two numbers that are repeated. Therefore, I converted this one table into only three tables with a note at the beginning to make the information more readable. And this is what I call a second look at tables. Another example is another water quality investigation where have parameters, years, but it looks that it was a very wide table, and he puts it in three parts. And the solution to this is to transpose the data in the table to avoid the repetition like this one. There is no repetition here. And the last example is an evaluation form for students in school contest where they have the name of the students. What I noticed that the criteria is repeated. The student was able to give a clear and well presented presentation. Look here. Again, the other students for different STEM plus task, but with the same evaluation repeated. Therefore, I said no, I should put the name of the students here and which track, is it junior track or plus track, and put the evaluation criteria once in the first column and use a drop-down list of evaluation marks from 1 to 5 to simplify the look of the table. Look the difference between this table and the very crowded tables above. My concluding remarks is that I tried to extract from different sources and select examples to show how to discover faults and correct some charts and to design a proper chart from data. And the selected samples show in the different sections how to improve published charts, convert data in tables to charts, convert paragraphs to tables to charts, and have another look at some charts and examine some pivot chart examples, as well as improve the design of some tables.